Hello and welcome back to Higher Maths Differentiation Stationary Points. So one more example. So question 3, a curve has this equation for x is not equal to 0. So that means that the curve will not be continuous at x equals 0. So the curve will not touch x equals 0. Okay, so it will not be a continuous curve like the previous examples have been. Find the x-coordinates of the stationary points on the curve and determine their nature. So we cannot use x equals 0 when we're looking at the nature of the stationary points in the nature table. So first of all, get it into a format we can differentiate. So 2x plus x to the power negative 1. Find dy dx, which will be 2 minus x to the power negative 2, or 2 minus 1 over x squared. Now remember, we need to state dy dx equals 0 for stationary points. So at this point here, we have 2 minus 1 over x squared equals 0. So multiply every single term by x squared. So we'll get 2x squared minus x squared over x squared, which is just 1, equals 0 multiplied by x squared, which is 0. So we have 2x squared minus 1 equals 0. Add 1 to both sides, divide through by 2, and take the square root. Remember, when we're taking the square root, we will get a positive and a negative square root. So our value of x, or values of x, will be x equals plus or negative, plus or minus 1 over root 2. What do we do next? We need to find the y-coordinate to go with the x-coordinates. So substituting x equals positive 1 over root 2 and negative 1 over root 2 into y. So 2 over root 2, which is root 4 over root 2, which is just root 2, plus 1 over root 2, which if we flip upside down and multiply will just give us root 2. So we'll get 2 root 2. So when x is 1 over root 2, the y-coordinate is 2 root 2. Substitute in negative 1 over root 2, and in a similar way, just going through in exactly the same way as the one above there, we'll end up with a negative 2 root 2. So those are our two turning points, or two stationary points. So let's have a look at each one. So negative 1 over root 2 is negative 0.707. Remember, we cannot pick x equals 0 because x does not equal 0 on this curve. So I'm going to pick a number just before negative 0.707, or negative 1 over root 2. So I'm going to pick negative 1, and the number just after it, negative 1/2. And substitute these into dy dx. So substitute in negative 1. So negative 1 squared is 1. So I've basically got 2 minus 1, which is positive. Substitute in negative 1/2. So I've got 2 minus 1 over negative 1/2 squared. 2 minus 1 over a quarter. So 1 over a quarter is 1 multiplied by 4 over 1. So I've got 2 minus 4 there, which is negative. You could just do this on a calculator. So I've got positive, then 0. When I'm substituting negative 1 over root 2, I will get 0 here. So I've got positive, 0, then negative for the gradient, which is increasing, then flat, then decreasing. So it's a maximum turning point at negative 1 over root 2, comma negative 2 root 2. Also need to check when x is 1 over root 2, or 0.707, to 3 decimal places. So I'm looking just before and just after that. So when I pick 1/2 and 1 whole, again, substituting a half. 1 over a half squared is 1 over a quarter. Dividing by a quarter, I can flip upside down, multiply by 4. So I've got 2 minus 1 times 4, which is negative. Substitute in 1, get 2 minus 1 over 1 squared, which is just 2 minus 1, which is positive. I've not written in the slope here, which I should have done. Missed that bit out, sorry about that, guys. And also substituting 1 over root 2. So 1 over root 2 all squared is 1 times 1 over root 2 times root 2, which is a half. So I've basically got 2 minus 1 divided by a half. Dividing by half, flip upside down. So I've got 2 minus 1 times 2, which is exactly 0. So as falling, so I should be writing this in, falling, then flat, then rising again. So it's a minimum turning point at 1 over root 2, comma 2 root 2. And after that, I've just made a quick sketch of the graph there for you.